Coming up on This Week in Radio Tech, we're going to Canada, just outside Toronto, for the CCBE conference. Chris Tobin's there, along with our guest, Anthony Kuzub. He's with Ward-Beck Systems, a name that you probably know. They've been around 50 years, and they're all into AES67. We're going to talk about that coming up on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store, with outstanding service, saving, and support. Online at bgs.cc. By the new Ruby console from Lavo. See Lavo in your future at lavo.com/TWiRT. And by the Telos Alliance, shaping the future of audio, inspiring you to create the most exciting and engaging audio experiences imaginable. Visit telosalliance.com/opt-in.
Hey friends, welcome into This Week in Radio Tech, the show where we talk about radio technology every week. Stuff from the microphone to the light bulb at the top of the tower, and lots of digital stuff. We probably a third to half of our shows are about something digital, because that's taken over the world. You know, when I got started in this business, we were all analog tape machines and calibration tapes and changing heads and swapping out new capacitors for old ones, and spent a lot of time doing that. And the world has changed. We still have equipment dying every now and then, but it's dying in a digital way because it's passing a lot of ones and zeros. But we got to keep up with this stuff and understand how it works. And one of the things that we have talked about a lot is audio over IP. That's not only where things are going, that's where they've gone. I've been doing this for about 15, 16 years now, this audio over IP stuff. And, pretty soon the television industry will be joining in on that. Well, my colleague, my friend here on the show, Chris Tobin, is up in Canada, and he's just outside Toronto at the location of the CCBE. We'll get Chris to tell us what that is in just a second. And he's also with our guest for the show, Anthony Kuzub with Ward-Beck Systems. And I have found Anthony to just be an amazing talent with regard to knowledge and practical application of audio over IP, especially AES67. So welcome into the show, and Chris Tobin and Anthony, welcome in. Glad you're here.
Hello, Kirk. How are you?
I'm
Thanks,
awesome.
Kirk.
Good to see you.
Yes, we're on location here in King City, Ontario, in Canada, and it's at the CCB. As you can see, here's the program for the weekend. It's good stuff. Today, I actually had some good shows. We had let's see, Francois from Octave Communications talking about what is it called? Safety Code 6.
Safety Code 6.
Yeah, which is the equivalent of OE65. And then this afternoon, we had a workshop with the gentleman to my left, to your right on the screen, regarding AES67 and how to play with toys that make crazy things happen, like this little thing called the Primo. Okay, so you plug in a microphone or two, and then through IP, you all of a sudden can be anywhere you like on your network, and there's some. So that's what we did, and it was an afternoon of reboots and programming and switch changing and
IP addresses,
addresses, and somebody else hijacked somebody else's piece of hardware across the network. So we did a little darknet stuff too.
Yeah, a little bit of ethics.
Ethics, yeah. We violated
ethics.
A few computer laws in some provinces, but yeah.
Somebody took my IP address.
They did. It was good.
Yeah.
Good stuff.
Awesome. Well, I wish I could be there. The CCB, and Chris, letter by letter, what does CCB stand for?
Central Canada Broadcast Engineers.
Okay, Central Canada Broadcast Engineers, and you're at the conference. They have that conference every year right after IBC. In some years, it's actually been a bit of a conflict. So obviously this year, IBC's been over for a week, and so you guys are there at CCBE, and I hope you're having a good time. I know it's a serious conference where really good cutting edge engineering talk is talked about. So and that's why we were able to grab Anthony from Ward-Beck Systems. So I met Anthony 2 or 3 years ago, and was really impressed with Anthony's not only knowledge but passion and enthusiasm about AES67. And he had some really cool ideas, some products that Ward-Beck Systems has been working on, and now they have a whole product line of AES67 stuff. So we're going to get into that coming up here. Right now, let's hear from the folks at Lavo. They have their own AES67 gear. Let's hear from our friends at Lavo.
There has probably never been a better time in history to buy a new radio mixing console. Today's consoles are more sophisticated than ever, with more features and functions than you can shake a stick at. But have you noticed how complicated they are? There's a sea of knobs and switches and displays and buttons. Some of them look like you might need a pilot's license to do your show. Well, a board doesn't have to be complicated to be powerful. Just look at the new Ruby mixing surface from Lavo. The first thing you notice is how smooth and streamlined it is. Ruby has lots of cool tech, but what it doesn't have is that confusing ocean of buttons that clutter things up. Now, we all know that there are some console features the jock only uses once in a while. So why dedicate controls to them? Ruby fixes this problem by moving those once-in-a-blue-moon controls to a touch-sensitive, customizable GUI that happily shares screen space with your other studio software, helping you fight control room clutter. Thanks to this design innovation, talent that use Ruby produce smoother shows with less errors. Controls that are used the most fall naturally to hand, while functions that rarely need adjustment are easily controlled with just a couple of clicks in the context-sensitive GUI. And Ruby has cool features you won't find on other boards, like Auto Mix, an intelligent gain writing function that guarantees the perfect mix for multi-mic morning shows and call-in segments. Dual mode snapshots that instantly switch the motorized faders between on-air and production modes, and enough DSP and I/O options to make even your pro sound pals green with envy. And because quality is as important to Lavo as it is to you, every console is proudly built to fanatically precise standards at Lavo's own factory in Germany. If you're ready to declutter your control room, do yourself a favor. Check out the new Ruby and the other cool Lavo radio tech at www.lawo.com/TWiRT.
And if you go to that website at lavo.com/TWiRT, it'll take you right to their radio products, and they'll know that we sent you there. And we appreciate Lavo's support of This Week in Radio Tech. Hey, it's Kirk Harnack, episode 414 of This Week in Radio Tech. Chris Tobin is at CCBE. He's reported from there before, and he's back this year along with Anthony Kuzub. And Chris and Anthony, you guys have spent the day together, seen some good talks, good presentations, and I'm interested to know, what you've learned and what Anthony has to share with us over the next 45, 50 minutes or so.
Well, I'll tell you what, today was a great day for RF safety stuff. That was this morning. And this afternoon, we talked about IP audio networking and where things are going, both for television and radio. So it's the audience here, we had folks from TV and radio together. And it was all about AES67, SMPTE 211030, right? Is that right? Yeah. And some of the tools that you can use, like MT Discovery and what was the other one? LAN? No, I got that right?
Oh, man. LANScan is great.
LANScan Pro.
PTP TrackHound.
PTP TrackHound. All the tools that you would need to properly build a network that would be robust to carry the multicast packets that you're going to be using. One thing you have to remember when you're going in this direction of audio IP, it's a busy, chatty network you're going to be building. It's not a bad thing, but you have to understand how to make sure the network, or we'll call it the highways, are properly outfitted so they can carry the traffic, large bits, large packets or small packets, or bursty, depending on what you're doing. So a lot of things go on. And then it's the other side of the coin, the switches, and how to make sure you program them correctly, what to turn on, what to turn off. What was that feature again? It's the energy?
Green Ethernet.
The green Ethernet. And it's not the color of the cable or anything to that effect. It's more about power efficiency and energy savings. And what it does is, I believe, it changes the packet size, or it tries to do bursty.
Yeah, it does it very bursty. So it wants to, take whatever is available, whatever is being sent, and groups it together and sends it as one burst.
Right, exactly.
But that's terrible. Then you lose all your synchronization, all your detail.
Right. And that's the other thing you have to remember when you're doing this type of work. It's the Precision Time Protocol, PTP. Timing is everything. And that phrase is probably more important now than ever before, because you're going to have all these multiple streams all throughout your network, or whatever you're doing, and they have to be synchronized. They have to be able to, it's like video splicing. You got to make sure you got the framing, time code is where it should be, because you want to be able to get in, get out properly, and not have a rolling video bar. So in this case, you don't want any audio dropouts to occur for the timing issues.
One does not simply receive 1 million packets per second.
Right. Exactly.
There's more to it. There's much more to it, I think, than people like to give.
Yes.
The system's credit for.
Oh yeah.
It doesn't work auto-magically. It's just regular magic.
Yeah, it's regular magic, but remember, you are in control. It doesn't just happen automatically. It's not.
This is true.
It's not universal plug and play. Whatever you do not think of it that way. And DHCP can be your friend, but sometimes in this particular configuration, you don't want to use it. Okay, so these are things you have to keep in mind, and that's why I think it's important, all of us, both TV and radio, to remember IT, broadcast IT, or the bits, as I call it, is a very important thing to understand. It's IT, but broadcast revenue is different from enterprise IT, which is not directly impacting the revenue as far as the end user is concerned. Like the IT administrator of a large network and say a Fortune 100 company doesn't feel the impact of him rebooting several workstations because they just did an update or maybe changed a list on a router. Right. But in the radio and television, what happens? We know. And there's a difference. So the broadcast IT person needs to be disciplined in the broadcast mission critical thinking and then apply that workflow to the IT world to be able to bring the two together. Just like back in the day, if you were building a transmitter site, you understood the plumbing of the RF and how things went. If you're in a television station, you understood time delays, time-based correctors, TBCs. You understood why those were important, why they're there, and how to use them. And that's the difference. And that's what you have to do now. We just moved into the future. You know, what we're doing today, anybody can do, but you have to understand why you're doing it. Like the green Ethernet. Why would you want to do that?
Why would you want to do that? Why? How's it going to affect you? But it's also, when did we stop engineering things?
Oh, yes, that's the other problem.
You know, it's when did we stop thinking that these things just magically happen and deploy themselves? And I think a lot of people take it for granted that, you know, this is a decision. This layer 0, I've made a decision. This layer 1, I've made a decision. This layer 2, I've engineered this solution. And when people stop thinking that you need to that this stuff just magically happens, you have to convince them of something very different. But it's there's a job associated with it. There's a task, there's a skill, there's knowledge, and like I was saying in the talk today, sometimes it's about the things that you ignore that are you ignore way more things than you actually deal with, and knowing which to ignore and what not to ignore is the magic key. Right. Is the magic key.
And as you point out during the workshop, you know, you talk about standards, right? We're all about standards and talking about there's all different phrases and reasons why and what a standard means to some people in a sarcastic way. But, you know, something as simple as the use of an XLR and what wires attached to the XLR pins 1, 2, and 3. Yeah. As you pointed out, pin number 2 is what? Is it high or low? Positive or negative? And why is it? Because
of standards.
Exactly.
And it's so that this microphone and your microphone can plug into our microphone preamp and be, you know, in phase with one another. And that type of thing. The AES did a lot of work and still does a lot of work with that. You know, I'm going to AES in New York. You going to AES?
I'll be there.
India?
Yes.
So there's all the super secret society meetings. Do you ever go to the super secret, like in the basements where they don't allow normal people? That's where I go. That's the reason I go to AES is to sit in like the connector group. I'm a big fan of the connector subgroup. There's a subcommittee on connectors, EMC. There's one on AES67, AES70. So, you know, like Greg Shea's at that. So I'll probably run into Greg there. And I always say that these arguments and these protocols come down to 5 guys. There's always like 5 guys that are at all of these meetings, and they pay attention to everything and they read everything. So I'm trying to be one of those 5 guys. I'm like, but it's going to take me 15 years to probably catch up to these guys.
Of course, that's why, you know, one of those 5 guys made that connector that's got 3 pins for an XLR. And there's a hole in the middle. This is true. Yep. And people are like, what's with the hole in the middle? Well, that's because you can put a 1/4-inch plug in there.
Oh yeah.
So now you got an XLR and a 1/4-inch plug. Now, whose standard was that? Who came up with that idea?
NETWORK. The NETWORKs did. But that's a proprietary thing. That's a proprietary.
That's why I was just going to go with that. That's why I was going to go.
But ultimately, what year was pin 2 hot? Do you remember what pin 2
I couldn't tell you which year, but I do recall in the early years of my career that pin 3 was very popular, being the hot side if you were dealing with folks in Europe.
In the Europeans, yeah.
So if you got equipment from Europe coming over here to the States or North America, you'd be like, what's wrong with my cabling? Why is it out of phase?
Oh, yeah. Or you get an unbalanced signal on one half of it and it just goes everywhere. And it's like, well, it's all over my grounds.
Yeah.
But at 91, I think it was 1991.
Oh, wow.
So it took, like 30 years of fighting and 30 years of incompatibility. It took 30 years of incompatibility to someone to standardize. But we have standards not to give credit to people. We have standards so engineers can do less work.
Right.
You know, like it's just something I need to reference. You know, what engineer is going to say, I'm just going to go to this chart. I'm going to go to my table. I'm going to look up XLR. I'm going to see that, it wires this way and away it goes. Ethernet, same thing. You know, headphone jacks. Well, tip ring sleeve, right is ring, so go that route. So, but the standards are very important, super important, and it really makes connecting possible.
Yes, yes, it does.
But AES67 is one of those things. It's of Axia, it's of Livewire, it is of QLAN, it is of Ravenna, it is of the telco, it is of EtherCon, it is of all of these things. And I like to say to people that it's not the lowest common denominator, but it's the most common commonality. And that in that way, you end up treating it very, very differently. But you have to remember that it is a commonality. It's not a unifier. It's just a commonality between these brands and manufacturers. So
that's true. That's true. Well, you were talking earlier about AES67 and an outside broadcast that was being done without the use of a desk or mixer console, depending where you are in the world. And talk about that. Talk about how something we're so commonly accustomed to, or as you pointed out, the what was it, the foosball of faders?
The foosball
of faders that can do gain control. How this event did not do that, and something new.
So I was asked by a major broadcaster, how do we cut post-production costs by 50%?
50%, he says.
And I said, do it live. And that's the approach they're taking. And what they're doing is they're virtualizing their mixing consoles. They're virtualizing their workflow. And what they're making the attempt to do is the show that we did was an award show. And they wanted to take the award show to the next level. And of course, the next level is a Dolby Atmos immersive mix. And, you run out of foosball players when you start dealing with that many objects, and then you need more players to deal with positional information. So ultimately, the post-production tool is the best tool to do it live. So this broadcaster, they used a piece of software called Pyramix by Merging Technologies, and they received all the Ravenna AES67 streams that they received from MADI, because broadcasters deal with MADI. They got all the MADI, they converted that to Ravenna AES67, and then mixed it in real time using the post-production tool. And it's very important to be able to use a post-production tool as a live tool, because you're essentially a mixing console. This is the once I realized this, it changed my life. Is a mixing console are variable changers of a database, right? So if I move that fader, I'm not moving audio. I'm changing a variable in a database. And then once I realized that, all the magic was gone. And so then the next step is, well, why don't you just access the database directly? And that is essentially what software is doing, is you're just accessing the database. Do you think plugins would sell a lot if they didn't have GUIs? Do you think we'd have like 300 compressors to choose from if they didn't have GUIs? I don't think they would sell at the same rate that they do if all the GUIs were just the database exposed. So a lot of people, they get into these workflows and they become comfortable with these tools, and it really changes how you look at all of this equipment. And when you start using off-the-shelf hardware and computers to do this type of thing, your opinion of it changes quite completely. But ultimately, the thing is, we're having a conversation. My microphone relative to your ears is important to you, and your microphone relative to my ears is important to me. And Kirk coming in from far away is relative to me. So with the approach that we took to latency is a relative term,
right? So
my microphone relative to me makes me either comfortable or uncomfortable. Your microphone relative to you makes you uncomfortable or comfortable. So with the DSP that happens inside the box, well, there's no latency.
Right.
It's where this round trip latency comes into play, and we're essentially just managing it creatively with software. Like here, we're using a web browser based vMix thing, and somehow it magically takes care of the mix minuses. But ultimately, a mix minus is pretty easy to generate somehow, somewhere, somehow. It's just you plus me.
Yes.
This is a mix minus. Mix minus everybody else is just you and me.
Yeah. Now, with that award show, what part did Ward-Beck play? I mean, I know we're talking with you. We're here because of Ward-Beck, so I want to just offer up. how did you? I know you said it was your participation, a company plus several other products. So what were your products to help contribute?
So we did the ambience record. So of course, with immersive sound recording, you want to have multiple microphones. So the proof of concept that we did, we took a split off of a set of microphone preamps and then took it to the network. So the proof of concept was the ability to take the microphones and put them on the network. The goal is to put these devices 2 feet away from the microphone. The goal is to eliminate, because a microphone is just an antenna. Everything with a long wire is just an antenna. So the sooner we can packetize it, the better. All of our devices are power over Ethernet. So you don't even need to feed power out to it. You just, set up the cable. When you're done with the cable, you just leave it for the cleanup crew, because it's actually cheaper to abandon cat cable than it is to pay your audio crew at 3 a.m. after they've been working double time to remove the cable. And it's a sad calculus, but at the same time, that's the reality of cat cable. It's when your major broadcasters are purchasing it by the pallet, your opinion of it changes. And the guy who terminates it, can terminate 100 connectors in an hour. So, just say, hey, I need a 282-foot cable, and poof, 280-foot cable shows up.
Now, you mentioned during today's workshop that you had several studios you put together, or for the event were put together. How many studios, and how much time did it take to put all this together?
Oh, it's massive. Well, so we had 2 rolling music production studios. So we had a music production studio that was called Livewire, which is a Toronto-based company, and Doug McClement showed up with his truck. Broadcast Audio Services, Anthony Montano showed up with his truck, and they did music mixes. So the idea is the 2 music axes, they would juggle from stage to stage. So we received a mix of them. We had 15 cameras, and those 15 cameras each had stereo microphones. So we had, every time they cut to a camera, there's a GPIO that triggers this, and it puts that fader up. And so we received all of that. We had 16 RF microphones, and then we had backup microphones to that, and then we had backup hardwire microphones to that. It got routed through MADI. So the traditional structure right now is a MADI router. And with MADI, you're stuck in this TDM-based MADI infrastructure. And MADI describes how I feel about it after a couple hours. And I no longer think of audio as a matrix. And MADI is a huge matrix, because you're forced into Gazinta by 64, Gazetta by 64, and matrixed inside. But when you're on a network, I think of it like a pool. And the analogy I use is, it's not like one of those pools that you have in your backyard. It's one of those pools that you see in Cuba, and you can go up to the bar and have a drink. And so I look at audio now as, well, this is a can of soup that I dump into the pool, and then anywhere else at that bar, whichever bar I'm at in Cuba, at the pool or in the pool, I just take that can of soup right out of there. But it's the label that makes the difference. And the label is the thing that manufacturers hide how they move around. And what happens with AES67, Rivanna, Dante, Livewire, WheatNet, all of these companies, is that mechanism is either proprietary or secret. And but what's happening is we're having more computer engineers enter the broadcast industry. Broadcasters have this IT battle fight, and now it's a matter of, well, let's hire the smartest guys we can, and let's skip the IT guys and go straight to computer engineers. And now the computer engineers go, well, how do I control it now? Like, where's my JSON presentation? I want to be able to send it a session description protocol. If all I'm moving around in these AMWA, ISO 4, ISO 5, all I'm moving around in is this little piece of text, like, we should be able to leverage that. And it's not about creating new standards. It's about going deeper into the ones we already employ. And that is a big deal. I'm not trying to create a new standard. I'm just trying to go deeper into the one we already employ. And it's an uphill battle for a lot of things. That's for sure. But we showed a couple different ways to make announcements. We used the Axia virtual sound card to demonstrate a going to call it a stream that you don't know exists. You don't know it exists until you either have an announcement or you know how to access it. There's no way it could be retrieved. But what we did was we used the Ravenna to SAP tool to create a proxy announcement for the rest of the devices to discover it. And we had a Wheatstone console, and we did the exact same thing. But the Wheatstone console and the Axia console, the certain little variables, like people don't realize that those variables inside the SDP can be manipulated on an as-needed basis, and not all manufacturers follow the same way of doing things. So this common language of SDPs is very important, and we're leveraging the telco industry quite a bit. So we have to keep doing that. We have to keep doing that.
Yeah. The SDP would be the same as if you're doing any work with VoIP, so you're familiar with that. So that's where the reference of the telcos comes from. So there's a universal platform that all this stuff relies on, is sitting on. We're just looking to apply it to our particular needs, our workflow. So VoIP is workflow for comms, communication, and then we take that same infrastructure and broaden it out to the broadcast.
Hey, can you guys hear me?
Yeah, we can hear you just fine.
Oh, okay, good. Hey, I wonder if Anthony would go a little bit deeper into an SDP session description protocol. I know that my experience with Livewire, with Axia Livewire, we didn't have an SDP, or at least not one that was visible to the user, until we started offering AES67 compatibility. I guess we didn't need one because Livewire to Livewire, we knew exactly what to expect. We knew how many channels it would be. We knew the sample rate. We knew the bit depth. We knew everything that was going to come in because we made it somewhere else at the other end, right? So, but SDPs, I guess, are necessary when you have little variables like, oh, guess what? This won't be 24-bit bit depth. This is going to be 16-bit bit depth. And instead of a 48 kilohertz sampling rate, we're going to do 44.1 here, or 96. And so an SDP describes that. And I'm going to find out from my own support guys if it's okay for me to put this in the show notes. But on a little secret page, Telos has a page where you can put in a Livewire channel number, and it'll give you the multicast IP address and what would be the Livewire SDP. Or you can put in the multicast IP address. It'll give you what would be the Livewire channel number, because that's easier to deal with the channel number. It's just a simple calc, and the SDP for that, in case you need an SDP for a Livewire channel. But all that said, Anthony, can tell me what else I may need to know or realize about what an SDP is.
I look at the SDP as the soup can label of everything. It is essentially a small piece. It's an object in the world of computer programming. It's an object, so it's just a block of text that contains information about the transmitter. Nothing about the receiver. So receivers receive the SDP and process the SDP. A good implementation of a receiver ignores the things it doesn't need. So if you have a piece of something in that SDP that is not needed by your receiver, it gets rid of it. So in the case of the Axia stuff, it was like you said, there are commonalities. So a channel or a stream or a flow is always 2 channels. It's always 48K. It is always 24-bit. So you have these known knowns. So those things don't change. And when you have a multicast, and in the case of Livewire, I believe, correct me if I'm wrong, you enter the channel number. And that channel number is essentially associated with a multicast. And that multicast is it's a known start and it's a known finish. And certain parts of it don't change. So it's very consistent. So when you're connecting, in the case of Axia, is you have things that don't change. So the need to receive an SDP isn't necessary, because all you're changing is the multicast flow. All you're changing is the multicast that you're subscribing to. And that multicast is always formatted in two channel, 48K, 24-bit wide. So where it gets interesting is, well, you can do different ports. Okay, so certain networks and certain forwarders only support certain ports. And it's like, okay, that's super cool. So boom, it's a variable. RTP profiles, Axia uses a profile of 96, and it's an arbitrary number is really what it comes down to. But if you don't have it matched up, it doesn't work. You have port numbers. you can specify in the SDP what your grandmaster clock is. So if you have a known, master clock, you can include that in the description and say, well, my transmitter is synchronized to this master clock. So in that case, at the receiver's point, what clock it is, what domain that clock is. Where these things start scaling uncontrollably is, you have thousands of devices on the network, and in our case, we're trying to segment into 2 channels everywhere instead of going 8, 16, and 32. Like for this podcast, I don't need a 16 channel interface. I just need 2 gazintas and 2 gazautas.
Nice. Yeah.
And this little podcast, we're doing this show on one of these devices that has 2 headphone amplifiers. So I have a headphone amplifier and he has a headphone amplifier, all off of one box. So this is a conversation piece. And with that, in the same way that Axia is delivering a 2-channel stream, it's much easier to manage. And it gets confusing when the streams are 64 channels wide, and you end up going backwards, and you have lookup tables. You go, well, I want channel 36 in stream 210, and you go, well, I got to go to my 210 lookup table, then I have to go to my 36 and see what it is. But the SDP, like I say, it's the soup can label. It's what's the soup? Well, this soup is made up of Chris and Anthony today. And, Anthony's on channel 1 and Chris is on channel 2. So that's a very interesting, simple little soup description. If I had a piece of tape and a Sharpie marker, I would write Anthony on this wire and I would write Chris on this wire. And the session description, I look at it as the replacement to augment all of your receivers, and it's a very universal thing, and it's mandatory by AES67. So the ability to receive, your receiver has to be able to process this, because right now we have 1 millisecond packets, and 1 millisecond, well, that's 48 frames, and that's 48,000 times, and each one of those has 24 bits in it. So the math changes if you change your data rates. And if you're transmitting long distance, you want 4 millisecond packets. If you want super fast, low latency stuff, the smaller the packet, the easier it is to process. But in the end, it's well, sometimes you just want it to work. And that's my thing. And that's where interoperability is a very, very important aspect of everything that we do. So it's very important to us.
Yeah. Well, you want to take away for Omnia Volt, Ed, or do you have something else?
No, I wanted to just make a quick comment. Since I've been involved with this audio over IP for a kind of a long time, just because I worked for the folks at Telos, I didn't even know what a SDP was, or that one was there or even needed until, as I said, until Livewire came along with AES67 compatibility or compliance, actually, and we added that. So on, at least from in my little world, if you've got a piece of Livewire gear and you want to send out, or you want to pick up the AES67 version of a stream, we got a button in our interface. You click that, and it pops up a little text box, and there's your SDP, your session description protocol. You can take that and copy it in your clipboard on your computer, and then go paste it into the GUI for the other end, right? For the end where you're trying to receive this. And you don't have to do a lot of typing, because there's a fair amount of text there to describe the audio channel. You just paste it in, and wham bam, the other end. Hopefully, if all of our semicolons and typing is right, then bam, you'll pick up that at the other end. And hey, 2 years ago, we did some experiments over at the Yamaha Corporation in Los Angeles, and we tried this out, and for the most part it worked. There were a couple times when there was, I see there's a semicolon missing here, or we need an extra line there. Oh, we got too many lines there on this SDP. We need to fix that. And so, but these SDPs can be really helpful in fully describing what you want to pick up on the network, and because they come from the generator of that stream. So Helpful stuff. And yes, we do need to take a quick break. You're watching or listening to This Week in Radio Tech. It's episode 414. Chris Tobin is along in Toronto, or just outside Toronto, and also Anthony Kuzub is with us. He's with Ward-Beck Systems, and you may have heard of Ward-Beck I've heard of them from a long time ago, and they made lots of cool metering stuff and switching stuff, and now, oh my goodness, they're into AES67. A lot of this is under Anthony's direction, and I think they're going good places, making the world, making accessories and important things that are compatible and useful and all that kind of stuff. So we're going to let Anthony talk about more of that in a few minutes. Right now, though, I want to tell you about our sponsor, Telos Omnia, the Omnia Volt audio processor. It's amazing. And here's my friend Larry Fuss to tell you about it.
More top radio stations choose Omnia than all other competing processors combined. Now meet the Omnia Volt, sharing lineage with Omnia processors like the Omnia 11, electrifying, competitive, market-leading audio in a compact one-rack unit package. With Omnia heritage built in, the Omnia Volt includes Dynamics Magic from Omnia Chief Algorithm Designer Cornelius Gould, including 6 AGC sections from start to finish, deep bass, warmth, and stereo enhancers, 5-band time-align limiter, the world's best presets to get you started right, and spectrally pristine final processing designed by Frank Foti. Omnia Volt users love its Quick Tweak feature. Quick Tweak distills years of processing knowledge and proven approaches into simple controls that turn you into a processing pro. Nail your signature sound in minutes using advanced presets or your own settings right from the Volt's front panel or a PC. Omnia Volt brings charisma to your station's audio. FM translators and low-power FM stand out among the crowd. AM stations maximize clarity and coverage. Digital broadcasts sound clear and musical without fatiguing artifacts. Smart design, clearly visible outside and inside. Input and output connections in analog, AES3, Livewire, and multiplex for FM. Automatic input selection handles redundant STLs. Remote control works with today's browsers, tablets, and smartphones. Idealized patch point for external watermarking. And hardened construction to withstand lightning strikes, surges, high RF fields, and harsh conditions.
The new Omnia Volt is stunning. Everyone will know you've got an Omnia on your station.
Omnia Volt is versatile too. DSP Core firmware alters the personality of Volt to fit your changing needs. FM, AM, digital transmission, or studio processing. Volt can even be used as a standalone stereo generator. DSP cores aren't extra cost add-ons. Download the functionality you need for free. The Omnia Volt. Omnia audio processing for any station, and a smart upgrade for aspiring broadcasters. Proven audio processing that'll leave your competitors in the dust.
Every time I meet up with Omnia dealers or Omnia users, I just hear great things about the Omnia Volt. I don't have one yet myself. I have some Omnia 1s and some old Omnia 3s at my radio stations. Oh, and we have an Omnia 7 at 2 of our stations. But man, the Omnia Volt, here's such great things about it, and I love making that ad. You may have seen me hold up a Samsung phone. I gotta tell you, that Samsung phone was good for nothing except for displaying the web page from the Omnia Volt. It worked great for that. So thanks a lot to Omnia for sponsoring This Week in Radio Tech. And of course, it's really all about the sound, and the Omnia Volt sounds just absolutely amazing. Okay, we're at episode 414, and Chris Tobin, along with Anthony Kuzub, are at the CCBE outside of Toronto, Canada. They've had a day of engineering. I guess they have another day coming up. And gentlemen, we're talking about AES67, how it is really changing the world of audio over IP for the better. I've always said, and Anthony, I think, well, you'll agree that, for some years, people looking at different AOIP systems, whether it was, say, Livewire, or something from Wheatstone, their WheatNet system, or Ravenna, or maybe Dante, they were looking at this and saying, well, hey, these things are not really compatible, and whatever I commit to, sounds like I'm kind of committed. Well, along came AES67, and Telos was a huge proponent of that. I mean, we were part of the original group that did that, and we knew there had to be a common language. Yeah, yeah, exactly. So AES67 reduces the heart flutter that people may have about committing to one particular brand or another, because it lets them all speak to each other when needed. Anthony?
Absolutely. Well, but AES67 leaves out more than it leaves in. There are certain things that are left out, and that is the incompatibility and the thing that people observe the most. It is, well, how do I make this connection? Well, you can make it manually. But if I have an automatic way to make it manually, it's automatic then. So like I said, it's just this SDP that moves around, and you never tune a transmitter. You always tune the receiver. So the receiver just changes. So it's never been the transmitter's fault. It's always been the receiver's fault. And how the transmitter broadcasts itself is the thing that everybody does differently. So the approach that we took in our device, in our implementations, is that, well, we support SIP, we support SAP, session initiation protocol, so from the telco, session announcement protocol, also from the telco, MDNS, Bonjour, which is Ravenna, which is essentially Apple, so it's like hooking up a printer, and then we support manual configuration, and then we support automatic configuration through JSON API presentations. So there are multiple ways to make a device hook up and talk to one another, and you're 100% right about the proprietary ecosystems. Vendor lock is a way to protect your business model, and that's a nature of the business when these things first came out. When these technologies were first on the network, you could patent it. You could own that technology for a certain period of time, but then when you realize that it's packetized serial data, the secret sauce is kind of run out, and you can't really patent it. It's a telephone running at 48K instead of 8K, and you go, well, it is just change the sample frequency and the bit rate, and it's just a high-end telephone. And once you get over that, you realize how these commonalities exist, and how these differences are actually, like you said, just businesses maintaining their business model, and that business model is valuable, and it's still valuable to this day. Incompatibility is still valuable to some people too, but ultimately, what companies like Axion, like WheatNet and Ravenna and the Dante side of things is they're selling reliability. And reliability is valuable to the customer. And unless the customer is educated enough to move these very simple session descriptions around, that reliability is on the shoulders of the provider. So it's that ISO 9000 specification. If a console is being used as an emergency paging system, there's liability to that. If 3 people got killed because my network switch died or something like that, like you could be found liable for these types of things, especially from a integrator's point of view. And when it comes to broadcasts, ultimately the goal is, because of AES67, if my console dies, I should be able to go right from a microphone preamp right to the transmitter. I should be able to circumvent everything in between and go directly to that. Or if a piece of equipment comes out of service, I should be able to patch around it, and by changing the path of the devices, and the reliability, and that 5 nines of reliability is very valuable to the consumers of this equipment. So it's a big deal. It's a huge deal. But AES67, being the great equalizer of all of these things, still does not include anything about control protocols. So my GPIO, well, that's proprietary. In audio, I have, for control, I have up, I have more up, and I have off. So if we can all agree on some method to say, look, what you got to do is turn it up, like phantom power, that's an up. Frequency, that's an up. Make it wider, that's an up. Make it narrower, that's a down. As soon as you kind of agree on this generic method for, right now, generic method for transportation. Cool. Okay, fantastic. Now, how about a generic method for control? How about a generic method for tally? How about a generic method for this, and this? And there are several efforts, one of them being AES70. And that is a rabbit hole I've gone down as well with some of your colleagues. And I've gone down the Ember Plus rabbit hole. I've gone down the SNMP rabbit hole. I've gone down the MIDI rabbit hole. I've gone down the MQTT rabbit hole. So that's the newest, most exciting one that has been proposed for AMWA, which is NMOS, which is ISO-07, IS-07. I don't like that they call it ISO 5 or ISO 4. It's like an international standard. No. It's IS-04. So we gotta be careful about that. We gotta be very careful about that. The same with Dante. You know, you ask any Australian owner of Audinate how to pronounce it, and it's Dante. So that's very important. That's very important. And you know, we as a Canadian brand, Canadians don't play to win. I'm going to say we don't play to win. We don't care about losing. I play for the tie. And I look at AES67 as the great tie.
It's a great tie.
It's a great tie. You know, who does it work with? Everybody. Who do you want it to work with? You know, hey, can you control this? Sure. Why not? Are you in your own island of things? You know, no, I can work with practically anybody. And you see that like Canada has a disproportionate amount of broadcast technology to a lot of countries. You have Evertz, you have Imagine Communication, you have Ward-Beck, you have Ross, you have Davicom. You have some pretty serious heavy hitters in terms of broadcasting, and I think it's true. Because we're so vast. We just have so many places to do it, and we have a lot of long hauls to deal with. So we've gotten pretty good at some of this stuff, and we have a Canadian broadcaster that supports the solutions that we're pursuing. The CBC is very different than how the American public radio works. Different mandate, different technical outcomes. The CBC in Canada here shares a lot of their technology, shares a lot of their discoveries, shares a lot of their implementation. They're very open. Like they're playing for the tie, they're really playing for the tie, because if everybody ties, then we can all work together. And that's a big deal. That's a huge deal when it comes to interoperability.
Well, and you guys have something that we don't have in America. You have a Tim Hortons on every corner. So everybody's
this is true.
Awake and buzzing.
I was just at IBC, and unfortunately, we have a Tim Hortons on every corner, because in Europe, it's just like, man, just give me 5 of those. I'll take just 3 more of those. Everywhere I went, there was like orange machines crushing oranges and turning it into orange juice. I'm like, this is heaven. I could live in this place all the time and consume your orange juice and delicious coffees. But yeah, Tim Hortons is fantastic, and it's become, actually it's owned by an American company now that I think about it. It's owned by Burger King, so it's just another American franchise.
Now here at the workshop, you were talking about that other new thing that's being proposed, the network audio device interface.
Oh, NATI. I call it NATI. Not another damn interface. Sorry, it's an internet show. I can swear a little bit. Not another damn interface. NATI. It's the great equalizer. It's the most common commonalities. So in AES67, there is mandatory. There are mandatory parameters. Mandatory. And then in SMPTE ST2110-30, there is a level A, B, and C, and that it's cause for confusion. So what I group it is the mandatory and the level A I consider to be natty. And I don't think it's going to catch on in terms of a word, but I hope with your help. I think it's great. This AES67 thing, it gets, it's the EBU doesn't like it being called AES67. Maybe a natty is the great equalizer. It's the tie.
That's the tie.
It is the tie.
Are you Matty or natty?
Natty. But what was the other? Network interface, digital interface, network audio digital interface, I think is really what it comes down to. But it's I had what was his name? Nuno from the Olympic Broadcast Services, and we had a fantastic conversation. It's just amazing to be able to pick a brain that does the Olympics of audio. And his whole thing was, look, I got too many choices. and my broadcasters have too many choices. And you guys, as a group and as an organization, just love to sit around and talk about their thing. And it's the winning and again, the tie. I want to play for the tie. And I think it's just, I want to be able to, and I think this is a common thing, I'm not alone in this, is I want to be able to plug this in and get audio out of it. That's really what I want to get out of it. I don't want to fight with it. I just want to plug it in and get audio out of it. And that's really what they want as well, as a consumer and as a distributor of thousands and thousands and thousands of signals. So right now they're stuck with this MADI infrastructure, which is very rigid, not very data rich. It's not metadata rich at all. You can encode some metadata in it, but not the same amount of metadata that you can include in an SDP. So for example, in an SDP, because it's from the telco, I can include an email address in it, and I can include a website address in it, and I can include all this extra information about my transmitter. So if there was a problem with it being received, you could put your phone number in it and say, well, that is at this location. So if you would like to reach that person, you could reach them there. Stuff like that it's really exciting to be able to leverage an existing standard, not something that isn't foreign to everyone. It's just saying, no, have you read deeper into
right,
it?
exactly.
Just you figure out how to do 50%, but there's this other 50% that enables you to do so much. And I think in the Axia, Axia supports Ravenna as well. So all of the Ravenna announcements are available to the Axia nodes and stuff. And we know this because we get together. So Greg, Shay, and I, and all those guys, we get together and we go to Texas and we play cowboy with Ethernet, and we all get together. We get in the same room and we go, okay, are you going to plug it all in? And I go, okay, I'm going to plug it all in. And your transmitters are on? Yeah, our transmitter's on. And we make it happen. And we get to play these experiments with different manufacturers, and we get to see. There's benefits to it because we get to see how other people do it. We get to see how other people interpret the standards. Like, a standard doesn't indicate that you are completely compliant to it. It means that you've interpreted it your way.
Right.
We have Chinese speaking and writing as a first language, and the way he interprets something can be completely different. And we were very lucky because a Chinese company took the time to convert AES70 documentation to Chinese for their engineers. So we were one of the first companies who got these Chinese documents and did an AES70 implementation off of the Chinese documents. And then we look at the English documents, and we now have to take it to a plugfest level. So with AES67, we do yearly, twice a year. Like this year, there was one in Wuppertal, Germany, and everybody who wanted to at least participate in it got to plug it in, turn it on, and that's what we shipped to IBC for these IP showcases. And then we did an interop in Texas, and we took that Texas interop and we moved that to NAB. And when we bring the IP showcase to NAB, it's a result of this tie. It's a result of this collaborative effort that makes this protocol actually possible. And so I don't know when the next one is, but we're doing one for AES. So AES New York, if you're going to AES New York, where the AIMS, which is the Alliance of, oh man, I should know this, Internet Media Stream. Oh, I don't know what AIMS stands for. I'm going to get in trouble for that. But it's an organization that is their mandate is to promote that this interoperability exists amongst manufacturers, and it takes an outside organization like AIMS to organize these events where it's kind of like the neutral territory. They're the tie again, back to the tie.
Back to the tie.
We're going back to the tie.
We have to make buttons made up.
Yeah, I'm not trying to win. I'm Alliance for IP Media Solutions. That's that. Thank you for that. And they do fantastic stuff, and they're trying to facilitate everything, and they facilitate conversation amongst companies, and that's a very interesting concept in 2018. But incompatibility costs our customers a lot of money, and incompatibility, it keeps us employed.
There you go again.
So
much for the tie.
So much for the tie. But then again, it's the automagically. Like, does this happen automagically? Well, what has ever happened in broadcasting automatically? Nothing. Even the automatic stuff required crazy amounts of maintenance.
Required intervention.
Yeah, you look at those old cartridges.
Guys, we're going to run out of time before too long, and I'd love to get a little closer look at the device that you've held up a few times.
Okay, here, I got to work
this AES67 device. Let's have a look at that. Kind of hold it still and tell us about what's on this.
Okay, so this is I'm receiving Kirk here. So this is a 2-channel microphone preamp, and it's a power over Ethernet device. So we tried to simplify. We tried to make it a magic black box. So this is a power over Ethernet dual headphone amplifier. So there's a headphone amplifier for the back and a headphone amplifier for the front, or there's a second version that has a line output on the back. And really what we did was we said, if everything in between the microphone and my ears is virtualized, what's left? And we said the headphone amplifier and the microphone preamp. And why do we have MADI? Well, it's to move microphones. Why do we have AES? Well, it's to move microphones. What natively supports AES? Like nothing. AES is not a naturally occurring sound wave. And so ultimately it's going to come off a playback system. It's for playback systems. And now that the playback systems are all virtual sound cards, we leverage this. So this microphone preamp is a 2-channel microphone preamp with summing built into it. So in the situation that Chris and I are dealing with, we are receiving an AES67 stream from a virtual sound card made by merging, because I'm using a Apple Macintosh here. So we are receiving it. I am able to receive that mix and mix it to our headphones. He has a front control. I have a back control for my headphones. He has one mic. I have another mic. And away it goes through the network through AES67, back up into the vMix, and away it goes. We have this on a switch, and you can do summing inside of it. So imagine language translation services.
Absolutely.
So I receive 2 channels, I duck those 2 incoming channels, and I can mix back up to the network. So within it, it has a summing engine that allows you to do that type of mixing. Descriptive video is now the law in Canada. So all programs and media have to ship with described video. So broadcasters are now, in the same way that they farm it out to stenographers to do the closed captioning, now they're going to have a new mechanism to have descriptive video done remotely. So this is where this box comes into play, because I don't actually use a mixing console. I don't actually use a mixing console, but I'm still able to mix with it. Privacy is a huge thing. We do a lot of consultation with legislative assemblies. And the whole thing is, well, if I have a 32-channel input box, all of those streams are available on the network. So somebody from the opposition party could listen in on it. But with this, if I mute the microphone on the front, it's not on the network. The network is receiving silence. So the ability to, then we have Python code for it. So if you want to control a dozen of these with a Raspberry Pi, you could control hundreds of these with a Raspberry Pi. So we're trying to develop a platform, again, with the tie. We're coming back to, we're just trying to make a platform for people to get creative on. And the trend I'm noticing is more computer engineers, less broadcast engineers. And all of our customers are saying, look, we would like to do this. And we have this guy who has the skills to do this, but instead he's making video games for fun. And we would like to employ him making a GUI and changing the way that the mixing console can work for us. And I know that, the Pathfinder, it's a perfect kind of tool for that type of engineer, where it's just like, I would like to do anything. I would like to do anything. Oh, and then the lamp stack, that we can also do SNMP control of this through a proxy. So we've got, the even more crazy is I can control it with Google Sheets.
What?
Okay, that's crazy. That's crazy.
Okay, so
let's go to our ad so we don't upset everybody.
I'll talk about that.
We can do that on the return.
Let's save. Tell you what, Anthony, I'd love to have a resource where our viewers can go to after the show. I'll put in the show notes where they can see some of the things that you're talking about, whether it's a presentation you did or a page on the Ward-Beck website or something. But let's give them a good tease for this resource after our ad. Our show, This Week in Radio Tech, is brought to you in part by Broadcasters General Store, a great place to get all the broadcast gear that you need, including the Broadcast Tools Pro Mix 4. I love this thing. This is a compact, full-featured mono audio mixing console. It's perfect for any broadcast studio or take out on remote. Now, it has 3 combination mic line inputs and a dedicated 4th input that can be switched between a balanced line input and the built-in USB audio interface. So you can plug this right into your PC, your Mac, even a Linux computer. Bam, it's a USB sound extension device off of that computer. You get 3/4-inch stereo headphone outputs. That's included with individual controls for volume, mix, and pan, and allowing custom headphone mixes that way. Other features include a switch selectable program limiter. So, you know, your talent that's not really watching the meters, they're not going to blow the output on it. You have XLR program output, monitor output with muting and volume control, mix minus output for connection to an external telephone hybrid or a codec, and an on-air light relay output. So all the basic things you need for a small mixer to have a really good time. It won't get in your way, and you can get your show mixed together. Plus, add audio from your computer or even send audio to the computer from this. A great choice for remote broadcasting and podcasting applications. Hey, you know, as engineers, we get asked all the time, hey, I'm going to start a podcast. What do I need to buy? Well, this is one thing you can point them at. The Broadcast Tools Pro Mix 4. It's got everything that you would need to do a small show, 3 microphones, an external input, the USB input, and plus a limiter, and send all that audio back to the computer for recording. It's easy to check out. You can check it out at broadcasttools.com and look for the Pro Mix 4. The Pro Mix 4 looks just like that on your screen. If you're watching your screen, I mean, it's just the cat's meow for something that's simple. And oh my goodness, I have got some talent at my radio stations that need something just this simple. And so there you have it. If you want to get one of these, contact my friends at Broadcasters General Store. You can go to their website at bgs.cc. That's easy, just 5 letters and a dot, bgs.cc. You can also give them a call at 352-622-7700. That's 352-622-7700. The Shute family, the Kirsten family, and those who have married into the Shute and Kirsten families are all there. And it's a wonderful family operation, very sophisticated too. I mean, don't let the family operation fool you. They have got this down to a great science, and they have for decades. Thanks a lot to Broadcasters General Store for sponsoring This Week in Radio Tech, and check out the Broadcast Tools Pro Mix 4. All right, we're going to wrap things up here pretty quickly. Chris and Anthony are just outside Toronto at the CCBE. Anthony, can you kind of give us a quick wrap up here of what our listeners would like to know? Tease them, and then we'll tell them where to go.
Tease them. Well, ultimately, I want to connect mouths to ears. That's really what we want to try to do, and we want to do it as simple as possible and have bulletproof solutions that Ward-Beck has been known for. We have a 50-year reputation to live up to, so we're working really hard in really long winters to deliver people a solution that they can have 5 nines of reliability for. So that's really what we're after, and I think we've hit the ball out of the park on this design, and we're excited to share it with the world. So there are some resources. I have a great website. Check out this for a domain name, NETWORKING.audio.
It's great.
Yeah.
So
a lot of good stuff.
So you can see all my presentations and links to presentations. So there's switching.audio, routing.audio, IGMP.audio,
XLR.audio.
XLR.audio is one of my domain names. Like.audio, that's me. Yeah, a whole bunch of stuff. The livewire.audio is still for sale. So I've been telling the marketing department at Axia to get. So there's networking.audio. Yeah. So this presentation. So if you go to the next slide or the slide after, so that's the goal. Go to the next slide. All of this information is a presentation that I try to go. So all their patching, switching, IGMP, multicasting. These are the presentations that I give on a regular basis. I encourage anybody to use those slides and to teach others of the ways of audio over IP. And we're here to help. Is really what we're trying to do.
Nice. I like that. That will prominently feature in our show notes, and I know that our engineers who are watching this would love to have that handy. I'm going to bookmark that, and it'll be in the show notes. Also, cheers. Chris, I understand you want to give thanks to someone there.
Yes, I just want to make sure everyone is aware that Kevin Liver, the president of Ward-Beck Systems, I want to thank him very much. He's here in the room with us. Thank you very much for making it possible for Anthony to be with us and making time.
Hey, Kevin.
As you can see, he's right behind us. So it's very important. Anyone in the audience watching and listening, if you have questions, definitely go to the website, talk to them. Today's workshop, it was an eye-opener. I talked with Dave Simon, Wally Lennox, two well-known broadcast engineers here in the Toronto area, and we had a fun time at our table.
Good.
There were 4 tables. Good. Everyone set up with little islands and networking,
but nobody won.
It
was all tied.
Oh, it was about to tie.
Everybody
all tied.
Everybody got a tie.
But we had a great time. The camaraderie among some of the folks. It was interesting conversations. I'll leave it at that. But great people. It's a great show. The engineers here in town in the region, top of their game. And today's workshop brought it out, and we had a great time.
I'm doing it again at WABI. So the Western Association of Broadcast Engineers has just confirmed that we are doing it. It is November 4th. I think I'm doing the same thing. So capture the flag at the AES67.
All right. So the West Coast folks, that's what you're going to be doing.
Awesome. Okay. All right. Hey, guys, we have got to go. I want to thank you both for being with us, and thanks to Ward-Beck Systems for making Anthony available. Thank you, Anthony, for your knowledge and your enthusiasm in sharing knowledge. I feel you, brother. I'm right in there with you. I'm glad you're on the show. Chris, thank you so much for basically hosting the show today. I really appreciate that, and working through that. Hey, coming up in the next few weeks, we've got audio processing trends is a show that we've got coming up. Also, we're going to be doing a show from Rattle and Hum, a bar in New York City. That'll be during the AES and NAB New York convention. And toward the end of the month, a really hilarious engineer named Jim Grum Graham is going to be with us. He is just a hoot. You're going to love it. Plus Mark Humphrey. He's been on the show before. He took a trip across America through the heartland, visited a lot of radio stations, and he's going to have some interesting comments on that for us. So, hey, we got to go. Chris, Anthony, thank you again for being with us. Sure appreciate you very much.
You're welcome.
And,
good day.
Good day. And thanks to Suncast for editing the show and producing the show. Really appreciate that very much. Thanks to also to Andrew Zarian, the founder of the GFQ Network. And thanks to you, our viewers and listeners. Appreciate you very much, and tell your friends about it. I'd appreciate that too. We'll see you next week on This Week in Radio Tech. Bye-bye.